A chap called Aidan recently got in touch and said he had a disposable vaping device. It was different to this one, but he said that when you squeezed it, it would actually trigger, it would actually run the heating element inside. This one possibly is a different construction, but I would guess they're all very similar. I went online and I found a listing for 3 disposable devices that came in about £9 for 3 devices in 3 different flavours. You've got the the menthol one, the berries one, and the one that I've already taken apart. It's in absolute pieces here, the tobacco one. It's notable that the tobacco one had this sort of cover over the mouthpiece. The other ones have a little rubber plug that goes in the end just to protect it during shipping from moisture leakage or something like that. Not really sure. But the idea is that when you inhale through it, it does the usual vape thing. It's worth mentioning, and it really is worth mentioning this, that this is nicotine-based liquid they've got in these. It's the salt nicotine, which is the, shall we say, it's what the tobacco industry likes to refer to as the greater satisfaction type thing. It makes it more receptive to your body to absorb. And at 20 milligrams, it's actually quite high. I take it that is 20 milligrams. VG 50%, PG 50%, that's the 2 glycols used. So it's the standard recipe. It's like 50% vegetable glycerine, 50% propylene glycol, and then a tiny quantity of flavouring added to that, and nicotine. It's worth mentioning, I don't normally use nicotine products, and this one, just 1 or 2 puffs of that single puff, in fact, will, after a time delay, I'll suddenly have a wee sort of nausea sensation. I'm going to make it worse. I'm going to try the berries one. Then I'm going to take one of these to bits to show you how they get taken to bits, because there are salvageable bits inside, and that's what we're really interested in here for a disposable item. Let's just have a wee puff on this berry one. That works as well. Okay, so let's take one to bits so you can actually see how it comes apart, because there is something prime inside. It's a decent little 300 milliamp hour rechargeable lithium cell. And they often use rechargeable cells in these disposable items because it's actually probably easier to get them in this range of sizes, and they contain less lithium than an equivalent non-rechargeable cell. So I guess we just have to get used to the fact that disposable products actually contain rechargeable cells. The capacity of this one is, incidentally, 1.28 watt hour at the 3.7 volts, and that gives a current capacity of roughly 300 milliamp hour. I have put a connector on the end and 2 new wires. These aren't the wires that came with it, because I was just going to show you something, and I've just dropped it. Okay, I won't show you then. I made a little adaptation to a TP4056 charger. Where is that? Oh, I know where it is. It's because I put it over there. Okay, that's fine. So I got one of these TP4056 chargers, changed the little current sense resistor so it charges at 300 milliamps. The value of the resistor I put in, I'm going to have to remind myself, 3.9K, 3.9K for resistor on these little boards. That R3 right at the bottom here is the sense resistor that sets the current. But I shall be retesting that. I shall test it a couple of times, and I'll put the results of its capacity in the description down below in this video. But here's the main thing. If you're strolling along the road and you see one of these that has been used up and discarded, because the type of people that will be using this device will be the hardcore smokers. It is aimed at them. It's got that super high nicotine content. If you find one, then the way to open it is to grip the end. And going by the appearance of this one, there's 2 little dabs of glue on either side, and you'll probably break the plastic. But this little tab here at the end has that glue in it. So if I gently squeeze it, which I don't think that's going to have much effect at all. So let's try. Right, going to have to snap it off then. It is snapped off. You snap it off like this. And inside is, if you carefully pull, you've got the little sensor that senses the inhalation. And let me just show you that, because it's this little plug here with a device that looks like a microphone. So let's disassemble it bit by bit. Now we'll zoom down just a little tiny bit for this, because otherwise you're not going to see anything at all. So you've got that little silicon bung in here, and we can take that bung out, and in the bottom of it will be what looks like a microphone with the LED pointing down the back of it. It's got a little LED in the back of what appears to be a microphone but isn't a microphone. It's a little tiny control module. If we then pull the contents of this, we get the liquid capsule and we get this fairly useful battery. The liquid capsule itself is really quite interesting. The rest of it is just, I don't know, can you see down the inside of that? It's basically a container with just a little port at the end that the rubber tip of the liquid cartridge goes into. And likewise, at the other end, you've got the cap. You've got two holes. One is small and one is large. I'm thinking, hold on, let me think of this. Let me just work out where that was. Liquid there, not really sure. I would guess that the big hole is the one that's actually going to be the vacuum device, and the other hole is just to allow continuous airflow through the unit, just to regulate that to get the correct sort of the airflow ratio. Let's take a closer look at this. The battery, which actually we nip through the wire there, but it doesn't really matter because there's nothing really major it could short in the vicinity. The battery has got two connections going to the little sensor device, and then one switch connection, the blue wire coming back, going to the vaping device, and the positive terminal of the battery here. Is it positive? That is a different battery. The other one has that nice marking system on it. But the one connection is going to the negative end, the red connection, with both wires coming out that are red, and the other is being switched to positive via this blue wire, probably by a little MOSFET in the chip in this. I'll show you that shortly. So what's this one rated at? 1.17 watt hours. So this is actually a slightly lower capacity one. The tobacco one actually had a slightly higher capacity. Okay, righty-ho. That's also useful to know. I can now show you what's inside these. I can break it down because I've already, as you can see from the fact I've taken it to bits here, I've already taken pictures and had it apart for taking pictures, and I'll show you how this whole thing works. So I shall shove that out the way and bring in the first exhibit, which is pretty much what I've just done here, really. Let's bring this in. Let's zoom out a bit so you can see the whole story here. We've got the battery here. There's a barcode on it. There's information. It's at 08570, which is 8mm diameter by 57mm long, theoretically. Let's measure that. Yep. 8mm diameter. Yep, 57mm long. And it's stated on here 1.28 watt hour. That converts to 345 milliamp hour. I've fully discharged that one and I've recharged it, and it came to approximately that value, but I was charging at too high a current, so that's why I've adapted this. And now I'm going to do another charge cycle and we'll see what it comes up to. I could actually put that, no, I'll wait till I've finished and then I'll do it. So that's what's in the unit. And if we take a closer look at the little device that's doing the sensing, it looks like a microphone. It is very tiny, so even this blown up picture is a bit grainy. There's a blue LED in the back. There's the positive, the negative, and the switch connection. And it just outwardly looks like a microphone, except for these two little vent holes, which, you know, a microphone could possibly have those as well. If you take it apart, then inside, you see, the other side of that circuit board has a little decoupling capacitor, and it's got a dedicated chip. RZC308A. I typed that into Google. I did an image search for it and it came up with absolutely nothing at all. It seems to be very much, well, I don't think there's going to be a market for actually selling these chips to the public as such. So what makes connection with this gold track round here is the base of this little metal tub here. This is Let me just grab the tweezers, in fact, and I'll show you it in real life. Inside the case, and that's the splattered case there, is this little metal ring with a piece of conductive film across the end of it. And the conductive film is super, super fine to the point, as I squeeze this, I don't know if you're seeing that slight distortion there, it's actually crinkling the film just by the very slight displacement of the metal. So this film sits inside this can, and there's a plastic ring, that's this plastic ring here, that goes round the outside of that and keeps it insulated from the can itself. But it does connect onto the gold pad, the gold sort of track round the circuit board here. On top of this mylar film is a little pink plastic insulator, which is super fine. Let me bring that in. It is, there's the, I'm not going to pick this up, I shall just stick my finger on it. It's basically, it's like a tiny little polythene washer. And then above that is this metal disc that sandwiches it between the end of the case. The case itself has, I've misplaced the case. No, there's a case there. It's got a little felt pad in the front. No, I'm really struggling to pick that up because it's all so tiny. And then, of course, the little circuit board here. Right, what happens here is that it's basically a pressure-sensitive switch. When you inhale, there's a sort of equalization of pressure through these holes, but initially, because the holes in the front are much bigger, as you continuously draw a vacuum, that film will be flexed slightly and it will touch this front metal plate. It can't touch it normally because of that insulating disc, but as that pressure change, as you pull a vacuum, it domes out slightly and touches this metal disc. And that signals to the chip that that you're inhaling. And what it does then, it does its timed output thing that it will switch on the output to actually power the heat element. And if you're pulling too long, it will automatically cut off, or if the switch has gone faulty, it will cut off as too. But it also, I don't know, does it do this sort of ramping up and down thing? Hold on. Yeah, it does. The little LED in the end, let me see if you can see this. Do you see it sort of ramping up and down? I hope that was in the shot. So it does this sort of blue glowing thing. It is absolutely what you'd find in a standard electronic cigarette. But that switches on the power to the vaping device, which is possibly the most interesting bit, because these are all just standard devices otherwise. The vaping bit is the bit that's sort of specific to this unit. And here's how it works. It has the metal core. This is the bit that as you pull air in, the air flows from the end of this module up through past the heating element. Now, I don't know if you can actually see in the other picture. Let me bring that back in and show you this. If I show you the other picture, this is the tank here, and it's full of liquid. It is full of liquid down to about this point, and then it relies on capillary action beyond that. There's a close-fitting sleeve here. And there's an oddity, because up here, there is this, a silicone ring to seal the end. There's a bit of sort of fibrous material like cotton wool just wrapped around there, and then to cap it off, there is the end cap that then mates to the mouthpiece, so when you breathe in, it pulls air through this. I could have shown you that on this. This is it here. And I'm guessing that that's maybe, well actually I was going to say maybe it's to absorb any slight leakage around that. I am seeing a slight moisture in there, so it is presumably then just to absorb very slight leakage. But this is very interesting because it controls the flow of current down by the fact it's absorbed by capillary action. It's not got an easy route to get down to the wick. You can see the heat element down here, that tiny little coil, and the sort of wick passing through it. If I switch back to this image of it in its destroyed state, this is the bit that is a close fit to inside the tube. So the liquid actually has to get down past the side of this by capillary action. It took a wee while to work out what was happening there. I had to blow through it rather than inhale to actually blow the vapour out it. And then once I'd blown enough sort of vapour out that it had to repressurize with air, you saw the little bubbles creeping up the side and then suddenly going blip out here and going up into the liquid. The heat element is just a standard little wound coil around the wick, and the wick gets put into, where's a pen? The wick gets put into here. So that's the wick splaying out from this side. And it then gets held in by this bit, which basically slides on around that. And it's got a little raised bump here with the holes for the wires that just pushes that wick firmly up and also holds it in a void in here with the little air hole coming through from the back that allows the air to sort of flow up past that wick and vapour as it's heated up to vaporise the e-liquid, and then the vapour itself then goes up this pipe to be breathed in. That was very hard to get off, as you can see from the fact that I had to Dremel this metal disc off. It was really clamped or glued tightly around this, probably part of the heat resistance aspect of it. I'd guess these plastics are designed to be fairly heat resistant. Anything else worth saying about this? Actually, I think that's more or less it. What else is there to say? Oh, there is. The heat element, I connected some wires to it. I could do that right now. Connect some wires. I'll put the bench power supply on. I shall chop a wire. Shall chop this wire. And I shall chop... I'll do this one. And if I strip these wires, what can I strip them with? I shall just strip them, because I don't think I've got it's very, very thin wire. I don't know if the wire that's coming out from the bottom here is actually just the actual heat element wire. It could well be. Seems like it would sort of waste a bit of current. But I suppose they're not really bothered about that. So if I turn my bench power supply on and I set the voltage down from 12 volts down to, yeah, that should be about right. I found that and I'll just blow through it this time when I power it up. You can hear it hissing there. Oh, so what, let's get the wires clamped on properly. I did a measurement. I'll turn the power off at the moment. I shall then blow through it. Absolutely nothing happens. Hold on. Oh, actually, you know what? The power supply has crashed again. Oh, it does that from time to time. So I powered it up directly, and at about 3.6 volts, sort of just an average voltage across that heat element, the current it was passing was 1.1 amp. And that gives an indication that the typical resistance of that is about 3 ohms. And there's no fancy circuitry, it's just basically applying it directly across the lithium cell. So as the lithium cell is depleted and the voltage gradually goes down from 4.2 volts, it will gradually get lower in output. Refilling it is not going to be that easy. This is one of the less refillable devices, partly because opening it up is quite destructive. I mean, if you were really hell-bent on refilling it, and you were happy with sliding everything out and then back in again, I suppose the easiest way, it's quite hard getting the rubber bung out the end. The easiest way might be just to drill a little hole in the side of this plastic tube, inject the liquid in, then put a bit of tape over it and then slide it back in. But to be honest, I don't think it's really worth refilling these ones. There's a little microphone type device. I call it a microphone. It's probably made in the same factory as the microphones because the construction is very similar, but it's just that little simple pressure switch. In fact, theoretically, if you were to suck on that, the little LED would light. But I'm not going to suck on it. That would be extremely awkward. But that's more or less it. So I'm going to go and I'm going to charge this battery now, and we'll see what capacity it is. Because certainly the main advantage of these things for us is that if you see them lying on the ground, you could scavenge the battery out of them. But I still have to say that when you compare the size of it, this one's disposable. And cost on its own is about £5. If you buy 3, it's about £3. But keep in mind that you can buy things like the blue, which is very nicely designed, has a very high output, and you can refill with a bit of devious. I made a video about that, the blue ones. You can refill them. But this one is designed to be rechargeable. That one has a rechargeable cell, but no means to recharge it. So I would say that this actually outperforms that This would be a better option, and if anything, when you look at them side on, this one's slimmer. But, just for generic, if it's the equivalent, I suppose, to a smoker of a packet of cigarettes. And likewise, Blue, which is a big tobacco company, relies on people buying its cartridges, which are full of the nicotine salt type liquid, the very addictive type version of the liquid, because it is the tobacco industry. But as I say, you can refill these. This was nicotine-free e-liquid in it, just as the novelty factor. But it was well worth taking those to bits. It was quite enjoyable taking them to bits. And nice to see it's got that little lithium battery. I'm going to think of a use for that now. It could actually run some lights or something for a decent length of time. And I like the construction of the liquid feed system and the fact, well, there's a good example. There's a little plastic thing that feeds with capillary action. You can maybe see the filament in the heater in the bottom there. See how the bubble in the liquid can't go past that barrier. It does rely on that close fitting between this and this to actually ration the liquid through. And that ultimately probably helps avoid leakage. This little buffer up here might also be for expansion and contraction. It might just give a little bit of give and allow, thermal expansion, contraction as the liquid expands or any trapped air bubble expands, particularly during shipping. But it's very interesting. It's a disposable, trashy item, but it does have that value to us of that lithium cell. And it's certainly an interesting construction of the liquid delivery system. It's actually really quite neat.